Welcome to Chapter 1 of the Catia V5 online course. Today we are going to see a piece that you are seeing on the screen. It is a simple piece, but we are going to explain very important concepts. For example, we are going to talk about the structure of the geometry tree, and we are going to talk too about important command operations of the sketch module as well as the pack command. Then we click on File and here we get the types of part that Catia has. Have many types of parts. Drawing would be to make a drawing. This would be to do an analysis of finite elements. Has many other types. The most important one that we need now is the pair, which is to make a normal part, a standard part. We click OK. Here we get the dialog box where we are asked to put the name of the part. In this case, this part we are going to call it valve or valve component. It asks us if we want to activate the hybrid design. The hybrid design is something, let's say, an advanced feature of advanced Catia. At the moment we are not going to explain it. We will explain it later. And if we want to create a geometry to the set, this is important. The geometrics, the set, are those parts of the geometry tree where the wire elements are stored. We call points, lines, or surfaces wire elements, and the elements that have a volume, the elements that have a thickness, these are the solids, and these are stored in the body. So now we are going to tell you if we want you to create a geometry for the set, and now we are going to see it in more detail. Here we already have what is Science's torque module. This is Saint's torque module. Here we can see the geometry tree. The geometry tree is where all the operations that we are going to do are stored. It is a very important part of Catia, since when we finish the piece, that everything we have done then will be recorded, and a person later comes to see what came to modify our piece. Here he will see how the we did, and it is what it will be used to modify it. The geometry tree is divided into geometric folders, is more or less like the Windows folders, in which folders the operations are saved. We have the geometric folders to the set, which are these like yellow ones that have the yellow icon here, and then the pens that have a green toothed wheel, which is where the solids are stored, which are those that have volume or that have a thickness. Then initially, as we said, that it will create a geometric to the set. Well, here we have it. We are going to change the name to the geometric to the set, and in properties, feature properties, here we are going to call it reference elements. We press OK, and we are going to create another geometric, the zeta. Now I will explain why we created another to create the geometric. The set, as we have seen, insert is given and then geometric to the set, and the creation dialog box appears. Here what it asks us is the name of geometric. The set tells us the fader, the father, that is to say where the geometric is going to be hanging from the set. In this case it is putting a valve component, which is fine since it is our piece. We are interested in it being at this same level but not as being included reference elements. That means that this geometry is going to place elements in the set within which we are going to create. That we are not interested in that because we had it selected. That it is orange means that it is selected. We click here on the screen and it is no longer there selected. Now we return to insert geometry to the set, and there is nothing in feature, which is how it should be, and here we are going to call it sketch. So now we have two geometrics. It is because we have two, because in the geometric being of elements of reference we are going to save all those points, lines, planes that we use as a reference to create geometry, and we will see it later. And in sketches we are going to save our sketch. Sketch and sketch is the same, and they are the two-dimensional figures that we use to create the operations, whether they are extrusion or revolution operations. Is the 2D figure that is always in a plane. Everything is that it is in a plane. So the 2D figure that is used to create solids, and we are going to Insert a body as well, because the body pair is always in all the pieces, but it is not initially recommended to save everything in the body pair. It is better to structure it. So to insert a body we give insert body, and here we have this body. We can also change the name. Button derecho gives you two properties, and here in feature name we can call it valves for example, or modisto valve. So we start, everything starts. When we start from the beginning it has to have at least two geometric elements to the set, one that be reference elements, another sketch, and a body apart from the pair body valve body. This is important to have a good structure of the geometry tree, which is something that is a good practice in a design with Catia. It is very important that our part is well organized, that the geometry tree is well organized, because it is important, because when we are making a very complicated piece with thousands of branches, if it is not organized nobody will know how to modify it, not even ourselves. When we go to work on the piece may have passed 6 months, we will know how to modify it, the same as someone else who comes to the best after a year. I tried to modify it. If it does not have a structure, if it is made in any way, he will not know how to modify it. He will have many problems. It will cost him much. Likewise, many companies are not even going to accept a piece made from us in any way. They have their policies, and within their policies is that the tree has to be structured in a certain way. Maybe it is not that good. Surely this is not the case. This is not just one of the structural forms, but this is the initial form that I teach you. And when you get to know the poster later on and have your criteria, you can modify it then, maybe instead of starting with 2 geometric to the set, because they start with 3, or instead of calling the reference elements they have a geometric being that they are reference points, another geometric set that are reference planes, another that are surfaces. But you will clarify this when you have more criteria, when they control more. For the moment all the pieces that we are going to make will start with this tree, with this structure. So now that we have this, the first thing we have to do is create a point at the origin. It is also a matter of structure to create a point. This point is going to be a reference point. To create a point we have to go, if you see here in the geometry tree, it's underlined valve body. This means that whatever we do now, mainly operations, are going to be stored in our tree in body valve. In this body now, as we want to make a point, we want to store it in reference elements. Right click on fitting work object and reference elements are highlighted. This is very important because now the point we make is going to be saved here, which is what we want. So now we are going to create a point. For that we come here to the point tool, we click, and here the point tool does not come out. There are many ways to create points. Well, a few. One would be entering the coordinates, another would be in a curve and giving it some parameters so that it defines the point on the curve. This would be in a plane, and we give it a series of parameters to define the point in the plane, on a surface, in a circle, sphere, tangent to a curve, or between two moment components that we will see it later in a moment. We are going to start with coordinates. We want the point to be at the origin, so we are going to give it 0, 0, 0, and we give it OK. And as you can see here, our point has been created for us, which is our origin. We could change the name. Right button, properties, and put origin. When changing the name is a matter of clarity. The more when we name the elements of the tree with descriptive names, the clearer we will have it, because now that we have these, this is what will always have to be when we are going to make a piece at this point. Also the origin. Now we are going to make the first sketch. For that we use this toolbar. This toolbar, which is the sketch toolbar, has two icons. Is that it is normal, and it is that is positioned to do the pieces. Well, you have to work with is that it is positioned. Let's say it's normal. It's a quick way to do it. It's fine when we are doing something of little importance, when we already have, let's say, a lot of ease and we want to do it quickly. But if we want it to do well, is a positioned sketch. What is the difference? He is that the positioned one, we tell him here exactly where we want our sketch, not only on what plane that we always have to tell him, but also where we want our origin to be. Everything is that it was in a plane, and everything is that it has an origin that is an original point and two axes. One horizontal and the other vertical, so positioned we give it all that data if we use it is that it is normal. It only goes to us to ask for a plane, but we are not going to define where we want our origin, and he is going to put it where he likes. So it is that it is positioned here, type position, that we do not have to change the references. It is the plane, that plane we want our scripts now. Not really, we don't care because there isn't nothing in the piece, so we can start with the XY plane, and the implicit origin means that he leaves it where he wants to put it. Catia here would put it in the origin of the piece, but his ideal it is projection point. This is a point that we are going to give him. That point he is going to project it on our plane, which is the X, and that is going to be the origin of our sketch. So always in all the pieces that we make we are going to use projection point. Why we are going to give it a point? For that reason we have created the origin, because we want our sketch to be in the X plane, and our origin is going to be at the origin and absolute, not at 0, 0, 0. So we give it origin here, it marks it, and now it also asks us for the orientation. The orientation the same, implicit, because we would leave it to your free will, but we are interested, it is up to us to define what orientation we want. We see it here. This that does not look very good here. Put an H is the horizontal axis and this is the vertical one. If we want with this, we are changing. For example, the horizontal is here, we give it reverse horizontal, it puts it for us here, and now we give it reverse vertical, the vertical puts it here. If we give it swap, it puts us here. It has exchanged us as we want it. Well, that is up to each one's decision. The idea is that later this is going to be put like this. So now we are going to start, we are going to put the horizontal towards here and the vertical towards here, so that when it rotates, when we click OK, this plane will become perpendicular to us, so it will turn like this, and the horizontal will remain like this and the vertical will stay that way. That is important for how visualizing the piece now is not so important because there is nothing in our piece, but when we already have here a with an assembly, a set, we are making another piece and we want to design another life. If it is going to be important where our other pieces are, our alternative pieces to the one time to visualize, then well, we already have everything defined and we are going to give it OK. We are going to explain all this and see in later pieces, because these operations are repeated whenever we make a new piece. There is to do these operations then. Even if you don't understand everything now, don't worry, because later on we're going to see it hundreds of times. So in the end this is going to be something very automatic. We already have our sketch here. Now we have to distinguish. Before we were in the module of pair of saint or module of 3 dimensions, that is where we have our solids. Now we will be in the module of sketch. It is different. The module of skate session is in 2 dimensions. Now we are in 2 dimensions, new 3. We are in a plane that in this case is the X7. All this that we see here is the X-plane, and this icon is one of the most important and most basic, that is to leave. If I click here and we leave our, is that if we go back to 3 dimensions, and here we have the most used skate toolbars that are profiles that are used to draw our figure. Here we can draw a profile that are lines and arcs followed by rectangles and different types of rectangles, and even rectangles that are called circles or arcs. Also, if you click on the little arrow, there are different ways to make a circle, and you can also make arc. Spline, which is a curve with certain parameters, is an advanced tool. Ellipse, if we want to make an ellipse, parabola, hyperbola, and so on, a very common line. And then other types of lines such as an infinite line or extra tangent lines and a constructive line, and then a point we also have. So we are going to start drawing something at the same time that we are drawing it today. I am going to explain to you, well, we are going to start drawing our figure. For that we are going to start with a line. For example, it is important when we are going to draw our first figure to think about where our origin of our origin is going to be. We are going to put it in the corner and click on it with line, and we see that we get a line, and we already have our first line. Now we are going to make everything approximate, then we will put the measurements when we see the dimensions, and we are going to give them. Now we are doing with a sketch, it is something that is going to, it seems to us that it should have the shape of our figure, but it is not bounded. That we do later. Now we make another line come. Now we are going to make an arc. For that we come here to the tool. There are several ways to make an arc. One is to make an arc giving it 3 points, and it draws us the arc that passes through those 3 points. This is also similar with 3 points, and this would be with a center, giving it a center and a radius. In this case we start from this. We are going to use this although our figure is the center, where it is assumed. Well, as it can be seen here, it is bounded with radii, so here it is indicating that the center is on this line in the middle. So since we already know that, we can take advantage of it, so we are going to tell it that the center is going to be on that line. In the middle, that circle appears like this. Filled means that it is selecting us in the middle. We click on it. We can also read here what it tells us. It is asking if we do not know what the next step is. We read then. Now it is telling us to select the point to define the good one. The starting point is this, and now to define the radius. As you can see here, the radius changes. In this case it will be up to here, and we move and right up to there. It tells us it is giving us the reference of what it will be coincident with the vertical axis. Then we click on its status that has been placed here is very important. It means it is a side of coincidence. It is indicating that this point is coincident with the vertical axis. So if I try to move it, we cannot only move along from the axis vertical because we have been given this coincidence. This coincidence can be deleted. We can delete it, and now this point is free. We can see it in both vertical and horizontal dimensions, but we are interested in that point because we were in the figure. That point is vertical, then we are interested in it. Then we give it undo, and now we draw another line. That's it. We already have our figure similar to the final one. Now we are interested in dimensioning. Now we are going to dimension. We always have to take into account two things, in dimension and in position. So we are going to dimension first in dimension, then to count in dimension. We are going to give this as the dimension icon. This is constraints. Yes, it can be restricted, but it can be translated as dimension, and it asks us for the dimension element. We start with the radius. We click on it, and as you can see, this radius is 67 millimeters. We are working in millimeters, but we double click on it, and now we give it the dimension that we want, which is 8 millimeters. It has become very small for us, but we can enlarge it, but the shape is maintained. This also for reasons of clarity, it is important to zoom in. So here we have, now we are going to give it another dimension in this dimension that will be 15. Then double click and we give it 15, and we already have it, although it has remained green. Now when it is white, it means that it is not defined. Since it lacks dimensions, we can move it. Now it is green, it means that it is completely defined. We cannot move it from one side to the other. I click it, I try to drag it, and it cannot be moved. If I would put another dimension, for example, this one already makes it pink. That means that there are excess dimensions. It is oversized. It is not necessary to set this dimension. This is wrong. A piece or a sketch never has to be pink. It always has to be green and white, because this day would mean that it is free, that it can be moved, or pink, which would mean that it has too many dimensions. So we will leave it green. So we already have it bounded in dimension, which are with these two dimensions, and in position. Why? Because we have defined at the corner of our sketch. That is to say, this point of ours is that it coincides with the origin. Since we can no longer move it when we have finished our sketch, now we click on the icon to exit the sketch. Ready. As you can see here, we have made a mistake. We have created our sketch or sketch 1 in elements as a reference. This is not right. We have said that we are going to save all the scripts in sketches, but we can easily solve this. We can simply drag it. We have dragged it, and now we have our stress in sketches very well, and now the only thing that remains is to destroy it. Obstruct it to give it thickness and create a solid. For that, we are going to use the pad command. It is the one used to destroy a sketch, and simply to give it an expression. We have just made another mistake. If you see reference elements are underlined and given here, the dealer was going to create the path within reference elements, but what happens which reference elements is a geometry to the set, as it is a geometry to the set is telling us that it is not a body and that the new operation, that is, the pad will create it in the body pair after the last operation of the body pair. Since there is no first thing, then it is creating it for us. This is not correct. It is not good, because that is why we have created our body. So I'm going to click cancel and we go to the body valve, which is where we want to create our operation, and we told it fanning work offset, and now if we don't get any warning box, then here we are in the path command. It's one of the most used. The first that it asks us is the profile, the sketch, that is to say that skate we want to destroy, the one we just made. We select here is that you can't change the name if we want it for clarity. If we put base profile or base sketch for example, and then it asks us for dimension, is to say how much we want to destroy, what thickness our piece is going to have. In our case it is 3 mm, so we give it 3 and it already makes our piece. Is a preview not here. We could define other types of, let's say leg until next until last, but we will see this later. The moment is dimension, which means that we give it the 3 mm if it makes a piece of dimension 3 mm, and then this operation mirror extends. It is also important here what it does to us is that it is not destroyed from our sketch, that is in the X-plane, and 3 up and 3 down are no longer studied. This is important because our initial plans will be in the middle of the piece. If we do not give mirror extend, our initial plans will be on the lower face, so when designing it, it is important to take this into account how we want it to look. It can be done in both ways. In our case, I think it is better to extend the mirror because since the piece is symmetrical, it has symmetry. It is good that our planes then in the planes of symmetry, but of course if we want the total thickness to be 3, then we have to give it 1.5 because it creates 1.5 above and 1.5 below. And now we click OK, and here we have our finished piece. As you can see, these steps have not been very complicated. Most of the ones we have taken will be repeated in 100% of the pieces that let's do it. Although later we will do it much faster, and then, well, the first piece is ready now. I invite you to go on to the second class where we will see another piece with some additional operations.